been with the permit section for about 4 years now. I permit mostly oil and gas facilities, emergency engines, foundries, and I've started doing some of the power generation. Today, this presentation will cover emission calculations, which are an important part of your PTI application. We will be going over how to quantify the emissions of all regulated air contaminants from all the emission units identified in your PTI application. We will go over the methods used to calculate emissions, including controlled and uncontrolled emissions. So let's talk about some of the different types of emissions. Uncontrolled emissions are the ones that exit the process into the air. Many emission units do not have a control device, so they only have uncontrolled emissions. If an emission unit has a control device, then the emissions exiting from the control device are considered controlled emissions. Sometimes not all of the emissions are captured. Those emissions are called fugitive. Not all emission units have quantifiable fugitive emissions. Boilers, for example, have emissions that exit directly to a stack. So there's no fume hood or fugitive emissions. What are the basic calculations for these types of emissions? We'll talk about that now. So the fugitive emissions are the uncontrolled emission rate multiplied by the difference between the capture efficiency of the control device and 100% divided by 100. The captured emissions, which are sent to the control device, are the uncontrolled emissions minus the fugitive emissions. Finally, the emissions from the control device are the captured emissions multiplied by the difference between the control efficiency of the control device and 100% divided by 100. Now, the total emissions are the sum of the fugitive and controlled emissions. There are 3 different ways to look at emissions. Each of these are important for your PTI application, so we are going to cover each of them now. But first, we're going to look at a definition. The first way for air contaminants is to be considered as potential to emit, or PTE. Potential to emit is a key concept in air permitting. The PTE is the maximum capacity of a source to emit each air contaminant while considering its physical and operational design. Applicability of state and federal requirements depends on the PTE as opposed to actual emissions. So PTE calculations must be based on operating at maximum capacity. As a default, we assume maximum operation is 24 hours a day, 7 days a week. And we look at emission rates in the short term of pounds per hour and the long term of tons per year. What we are talking about here is also called the unrestricted PTE because it does not take any permit restrictions into account. Now, projected emissions are the expected annual emission rate of air contaminants from an emission unit. This should be based on how you actually expect to operate the emission unit in the foreseeable future. Projected emission calculation should be considered, or should consider the control equipment that you plan to use. Projected emission rate is often much lower than the PTE. They are basically your realistic best guess as what your emissions will be. They aren't required in your permit application, but they can be very helpful to let your permit engineer or help your permit engineer to determine appropriate emission limits. So now we will go on to an example to explain projected emissions. So let's say your current emissions are 15 tons per year. In the foreseeable future, your business is on track to increase production by 25% to meet customer demand. So you would take your current emissions multiplied by 1.25 to estimate that the projected emissions would be due to the increase, or 18.75 tons per year. Now, the maximum allowable emission rate is just how it sounds. The max allowable emissions for each air contaminant as allowed by your permit, taking into account any legally enforceable limitations like material throughput or production limits. In a permit application, it is helpful if you propose what you think your maximum allowable emission rate should be. One way to do this is first determine the projected emission rate and then incorporating a buffer or a margin of compliance. The margin of compliance should be designed to allow the source to continue operating in compliance with its PTI, even with an unexpected increase in production demand. Once a permit is issued with limitations, the maximum allowable emissions is your new restricted PTE, which is what most regulations are based on. So here is an example of an emission summary in an application. We'll keep it simple and just one pollutant of particulate matter, but your application will probably have many pollutants. For the long-term emission rate in tons per year, the calculated unrestricted PTE is 18 tons per year. Based on how they will actually operate the equipment, the projected emissions are only 12 tons per year. But in case business is booming and they happen to increase operation more than anticipated, they are proposing max allowable emissions of 15 tons per year, which is about 25% higher than they projected. With the short-term emissions, they have calculated their PTE as 1.4 pounds per hour. This could be based on a manufacturer's information or other calculation methods, which we will get into later. Just in case the emissions are higher than they anticipated, they are asking for a limit of 5 pounds per hour, which is about 20% higher than their calculated PTE. You are not required to put projected and max allowable emissions in your permit application every time, but it is often very helpful for a permit engineer because it helps us give you a permit that is appropriate for your business and doesn't have limits that are so high that it causes you to have extra burdensome requirements. There are different methods to calculate emissions. There are source-specific emission factors provided by EPA, other agencies, or equipment vendors. Mass balance is the amount of material input minus the output. Stack test data of similar sources can be used. Emission limits may be contained in an existing permit to install or in a regulation. Finally, engineering judgment is a product of experience mixed with engineering education to make calculated decisions. This method will need a large amount of documentation though. So emission factors are a common tool for calculating emissions from processes. An emission factor is just a ratio. In most cases, it's a ratio of the amount of pollutant emitted within some measure of process activity, such as throughput of material. The emission factors rely on the assumption that a linear relationship exists between the emissions of air contaminant and the process activity level, such as the example on the screen of 5 pounds of PM per 100 widgets. Now, emission factors can be found in a variety of sources, many of them published by the US EPA. The chief website is a starting place that can direct you to other sources, including AP42. This is the most common cited source of emission factors. The emission data from an AP42 document have been gathered from source tests, material balance studies, and engineering estimates for criteria pollutants and TAC emissions. It is divided into chapters by the different industry types or emission unit types. WebFire is like a database or spreadsheet version of AP42. It contains EPA-developed emission factors for criteria pollutants and HAP emissions for different source types. More information on these sources of emission factors and others can be found in Chapter 5 of the workbook. Now, here is an example of what the AP42 emission factors look like for diesel-fired engine. There are ratings for each emission factor, which shows the reliability of each value. Emission factors with the highest rating of A have a lot of data backing them up, and those with lower values might have been based on only 1 or 2 emission test results. The less reliable an emission factor seems, the more likely we are to require emissions testing in the permit. A mass balance is a method of calculating emissions that is based on the concept that everything that goes into a process must come out of that process. It is a very common method for determining emissions in situations where a high percentage of the material is lost to the atmosphere, such as a coating line. For many surface coating operations, it can be assumed that all the solvent in the coating evaporates to the atmosphere during the application and drying processes. Inputs are raw materials added to the process, which for a coating line includes coatings, thinners, solvents, and uncoated parts. Outputs are the coated product, solid and or waste, liquid waste, and air emissions. So to calculate VOC emissions from a coating line, we need to quantify the VOCs in the inputs, which includes coatings, thinners, and solvents. We would also need to quantify the outputs, which includes VOCs remaining in the final product and VOCs collected in any solid or liquid waste. Using a little algebra to solve for air emissions, we subtract known VOC outputs from both sides of the equation. What we have left is an equation that says the known VOC inputs minus the known VOC outputs equals the air emissions. Another method to estimate emissions is using software or computer models, which have been developed for several types of emission units and facilities. The workbook has a link to the EPA website where these tools can be found. A third method to estimate emissions is a performance test. A performance test, or stack test, is used to measure the concentration of air contaminants in the exhaust stream. Tests are conducted according to established procedures. Stack tests provide a snapshot of emissions during the period of the test and predict a more accurate short-term emission rate than the mass balance approach. The approved permit to install may require a stack test shortly after the new emission unit begins operation to verify the accuracy of the emission estimates. The Michigan Air Pollution Control Rules and federal air quality regulations, such as the New Source Performance Standards, or NSPS, and National Emission Standards for Hazardous Air Pollutants, or NESHAP, contain emission standards that limit emissions of specific air contaminants from certain sources. These emission limits can be used to determine the allowable emissions from the emission units that are subject to the standards. One example is the engine NSPS. Emission limits in grams per horsepower hour that engines are certified by the manufacturer to meet. If you know you will buy a certified engine, but don't know which engine, you can use the max emissions allowed by the NSPS to do the calculations. Lastly, a good engineering judgment is the last resort to estimate air contaminant emissions. This approach is used when no other emission factors or methods appear appropriate. These calculations often use scientific theory and/or laws to estimate a conservative assumption of the emissions from a process. These calculations are usually complex and include large safety factors to ensure compliance with an emission limit. A large amount of documentation is required with this method to verify the factors used in the assumptions.